Okay, so in this video, we will solve this exercise that says, Adam sets out for a hike from his camp at point A. Okay, we see the diagram below. Here is the diagram. So he hikes at an average speed of 4.2 kilometers per hour for 45 minutes, on a bearing, okay, so an angle of 35 degrees from the camp. So this is the bearing, okay, so the angle like between AB and the north, this north direction is 35 degrees. So on a bearing of 35 from the camp until he stops for a break at point B. So find the distance from point A to point B. This should be an easy question. Okay, so if you want to try, please go ahead and pause the video. I will just go ahead with the answer. So if he hikes at this average speed for 45 minutes, yeah, so then we just have to do this, like this simple, like regla de tres simple, okay, like I don't know how to say it in English, but so if we just think that he, okay, so Adam in 1 hour, so 60 minutes, Adam does 4.2 kilometers on average, yes? So, I mean, this is on average, so this doesn't mean that every 60 minutes he does 4.2 kilometers. I mean, well, sorry, so the thing is, for example, if Adam was traveling for 2 hours, maybe the first hour he did like 8.4 kilometers, and then for another hour he just rested or something like that, or maybe first he did just 8 kilometers and then 0.4 kilometers. But the thing is, on average, the speed is this one. Okay, so on average, he will do this distance. So using this average speed, if in 60 minutes he does 4.2 kilometers, then in 45 minutes, how many does he do? So the answer will be just multiply these two and then divide it by 60. Okay, so if we do 45 times 4.2 divided by 60, this will give us 3.15. Okay, so this is the answer. The distance is 3.15 kilometers. Okay, this is the answer. Another way to find this out that actually will be the exactly same thing, but just thinking about this in other way, is thinking how many time of an hour does 45 minutes represent? So 45 minutes represents, well, 45 over 60 parts of an hour, right? Because an hour has 60 minutes. So this will be something like 0.75, right? So 3/4. So now we will multiply this by 4.2. But if you look at the formula we used, it's basically the same, right? It's just instead of first multiplying and then dividing, first dividing the 45 by the 60 and then multiplying by 4.2. Okay, so this is the exact same thing. So this is the answer. The distance between A and B is 3.5 kilometers. Then B, Adam leaves point B on a bearing of 114 degrees. Okay, so the bearing will be this one. This will be 114 degrees, and continues to hike for a distance of 4.5 kilometers until he reaches point C. Okay, so here is from B to C. This is the path Adam took. So show that ABC is 101 degrees. So for this, we won't use any formula from the booklet, but what we have to realize is, since this and these are parallel lines, okay, for example, something that we can think maybe from the IGCSE or from another math year is that this angle is the same as this angle, right? So this angle is 35, so this angle is as well 35, which this means is that this angle here will be 180 degrees minus 35, right? So the supplementary angle. So this angle in pink will be 180 minus 35, which is 145 degrees. Okay, and after realizing this, what we, oh, actually this wasn't even needed, right? Because if we take a look at this angle now, okay, so this angle, doing the same logic, using the same logic as for the pink angle, now the orange angle will be 180 minus 114, okay? So this will be, if I'm not mistaken, 66 degrees. So the complete angle, which I will do in black, the complete angle ABC will be 35, so this one, yes, plus the orange one, which is 66. So in total, the angle will be 35 plus 66, which is exactly 101. Okay, so this is kind of a tricky question, right? Because we are in the IB and we have to show this. It's kind of difficult to really know if we are actually showing this, because we can do like some tricky thing that will leave us with the 101 number, but maybe the logic is not correct. Okay, so we know the answer that we want or we need to reach, but we won't be sure if the logic is correct. Okay, but anyway, this is the answer. Okay, now for to C, oh, we have to C to D to E, O, and to F. Okay, so this video might take a while. So to C says, find the distance from the camp to point C. Okay, so the camp was in point A, if I'm not mistaken. We can just go up and, so from his camp at point A. Yeah, so the camp is at point A. So we need to find this distance, okay, in black. Now, how can we do this? Let me think. Oh, right. So the thing is here, I mean, if we had this, the length of this side that we actually have it, right? It's 3.15, I think, from before, right? And if we had this, then knowing one angle that can be, for example, this one that we already know it's 101 degrees. So this will give us, this will help us with the cosine rule to find the black side, which is AC, which is what we want. So do we have the side BC? Now you can pause the video and check. So, oh, right, so they already tell us, right? So from point B, he continues to hike for a distance of 4.6 kilometers. So we already know that this side is 4.6. Okay, so now, 4.6. So now what we have is a triangle, yeah, for which we know two sides and the angle in between. Okay, so since we know the angle in between, yeah, and we don't have any information about the other two angles, then the only thing we can use is the cosine rule. If we go to the formula booklet, so we want this side, okay? So we will call this side C. Let's do it in black. So this will be side C, okay? So let's say this is A, then the red one is B, and then the angle in the middle will be necessarily the angle C in capital letter, okay? So now we have to do this calculation. So first of all, since the calculator will do the cosine in radians, we could do two things. Either go to the setup and change this instead of radian to degrees, yeah, or just convert 101 degrees to radians. How can we do that? Well, just knowing that, for example, 2 pi is 360 degrees, then 101 degrees, how many radians it is, right? So here we have radians, here we have degrees, and we will just multiply this and then divide. Okay, so these are the two formulas, the two ways, sorry, of doing this. So since I already changed the calculator to degrees, let's keep it like this. So now, for example, the cosine of 90 should be 0, right? Perfect. If this was in degrees, in radians, then cosine of 90 wouldn't be 0. This is kind of a trick to check whether our calculator is in degrees or in radians. So now that we have this, we will just use the formula. So c squared will be equal to a squared, so 3.15 squared plus b squared, so 4.6 squared, and this minus, right, 2 times a. Okay, so I think I'm writing a as 3.15 and b as 4.6, but it's exactly the same thing, right? So 3.15 times 4.6, and this times the cosine of the angle in degrees now. So 101. This is actually nice because even if we don't know how to reach the solution in 2b, we already know that this angle is 101. So this won't be like something to like an obstacle in 2c, right? So in 2c, we already know the angle, whether we knew how to find it or not. So this is something that the IB sometimes does, and it's important to notice that it can happen, right? So maybe we will have 0 point in 2b, which is 2 marks, but maybe in 2c we know how to do it, so we will have the 3 marks. Okay, so we know that the angle is 101, so we just do this, and this will be the value of c squared, right, according to this formula. So we just have to do the square root of this. No, sorry. So the square root of the ans, and this will be 6.05. Okay, into 3 significant figures, notice that this is 6.05. The solution will be C. So if I clear everything, so this will be, sorry, so this 6.05 in which measure, in which unit? Kilometers, right? Because everything is in kilometers. Great. So let's go on to D. So now we have to find the angle BCA. This is a nice one. So we need BCA, right? So this angle. Now what we will use is, instead of this, the cosine rule, just the sine rule. Okay? Why? Because the sine rule marks a relationship between 2 sides and 2 angles. Okay, so actually 3 and 3, right? But if we take a look at, for example, this first part, knowing 2 sides and 1 angle, then we can get the other angle, right? So if we come and do this here, let's say, for example, let's say this will be our side C. Okay, so let's make this our side A, okay, and this our side B. So this will be our angle A in capital letter. Oh, sorry, so this will be our side C. It's the same, but basically let's just do it like this. So this will be our angle B in capital letter. Okay, so the opposite to the side B will be B, like the angle B, sorry. So now we know from the sine rule, yeah, that the side A over the sine of angle A is equal to the side B over the sine of angle B. Okay, so let's write this here. So A over sine of A is equal to B over sine of B. Great, so now let's just write the values. So A was, I think, 6.05, maybe I'm mistaken, I didn't write it. So if A is 6.05 in kilometers, right, everything will be in kilometers, over the sine of angle A, and which is angle A? The angle ABC, right? So 101 in degrees. So this will be equal to the side B, and the side B, we already know it's 3.15, again in kilometers, divided by sine of the angle that we don't know, the angle that we want to find, right? So if we just do some things here, we will have that the sine of the angle B will be equal to 3.15, sorry, times the sine of the angle 101 degrees over 6.5. Okay, so if we come to the calculator, since the calculator is already in degrees, then I don't have to do anything tricky, right? So I will just do 3.15 times sine of 101, and this I will divide it by 6.05 if I'm not mistaken, and this gives us the sine of angle B. Since we need the angle, like the angle, the actual measure of the angle, and not its sine, then we will just do shift sine of ans, right? And this will give us 30.7 degrees. So this is the angle that we are looking for. So the angle ACB, if we look at the letters, the angle ACB is 30.7. That's the answer. So I will clear everything. So, BCA, so ACB is the same as BCA, so 30.7 degrees. This is the answer to 3 significant figures. Great. Now, Adam's friend, Jacob, wants to hike directly from the camp to meet Adam at point C. Find the bearing that Jacob must take to point C. So the bearing they are asking us is basically, if I'm not mistaken, this one, right? So we already know that this small angle will be 35, so we just need to find this angle, right? So we could do this, for example, with the sine rule or maybe the cosine rule, but something that will be easier, and I will just mention this because the video is getting longer and longer. So how to find this angle? Well, the easiest, I think, the easiest way is just, we know that this is 101, and we know that this is 30.7. So this angle will actually be, since this is a triangle, this will be 180, which is the total sum of the three angles, minus 101 minus 30.7 degrees. So if I am not mistaken, this should be something like 48.3. I could be mistaken, but anyway, right? So we just do this calculation. Let's just in case do it here. So 180 minus 101 minus 30.7, 48.3, excellent. So this is the angle that they are asking us. Oh, actually this isn't, right? So the total angle, this one will be, sorry, I will just maintain the red. This angle will be 35 plus 48.3, and this is 83.3. So this is the answer. I don't have the masking here again, but I can upload it and you can check if this is correct, and if this is wrong, you can try to find out why, but I'm trying to make this correctly. So this is the angle, so this is the bearing, right, that Jacob must take to point C. And now to finish this very long exercise, Jacob hikes at an average speed of 3.9 kilometers per hour. Find to the nearest minutes the time it takes for Jacob to reach point C. So here, what we just have to do is find the length of AC, which I think we already did, right? Yeah, so in 2C, we already found the distance from the camp to point C, which I really don't remember because I didn't write that down, sorry. So if we have this, for example, let's do something, I really don't remember. Let's say the measure of this is, I think, 6.05, but I don't remember. So if this was the measure and Jacob hikes at an average speed of 3.9 kilometers, then we can just do, if in 60 minutes Jacob does 3.9 kilometers, how many minutes will it take to Jacob to do 6.5 kilometers? So we do this cross multiplication and the division. So the calculator will tell us that the amount of minutes that Jacob takes to do this hiking is 6.05, sorry, times 60 minutes divided by 3.9, and this will be in minutes. So 93.07. 0.1, let's say, right? So if it is to the nearest minute, what we need to do here is just round up this. So in minutes, this will be 93. So the time it takes for Jacob to reach point C to the nearest minute is 93. This is the answer, and with this we conclude the whole exercise.